My name is Andrew Butterfield, and today we'll be looking at the role of aspect and slope percent in chaparral ecosystem, looking at both burnt and unburnt vegetation. The site location is in Mission Trails Regional Park in the city of San Diego. The site is located within a over 5,000 acre open space preserve. The site is accessed through the city of Santee as well as the city of San Diego. The site vegetation is not maintained except for trail maintenance, and the site has had at least 2 fires over the last 10 years. The study site is dominated by Chaparral plant community. It is located within a protected regional park. It is part of the wildland-urban interface. Most of the fire activity in this area is due to human activity. This site was chosen due to the fire hazard risk, accessibility, and plant diversity. Again, the site is largely left alone except for trail maintenance and upkeep. The site location can be seen here. The green outline is Mission Trails Regional Park, and as you can see, the site location is in the classification of very high, which is likelihood to burn if there is a fire. The site is dominated by the chaparral plant community, and common plants are laurel sumac, flat-top buckwheat, chamise, and California sage. The picture at the top left does show some open green spaces, non-native grasses. However, the picture at the top right is more accurate as to how densely packed the plants are in this area. The 2 species that were collected were flat-top buckwheat and California sage, as this gives a good representation of the area. There are many hills in this area, most facing west and some to the east. The percent of cover is high, except in the recently burned area. In May of 2017, a small fire moved through the hillsides from the west to the east and up the hill. This was due to winds coming from the west. Trails are present in this area, some man-made and some animal trails, which allows access to the different sites. Every precaution was taken to avoid impact to plant and animal life. The vegetation in the unburnt area is thick and dense. In the burnt areas, wildflowers are blooming and several native plants are returning. The California chaparral shrublands are prone to wildfires due to high temperatures, low humidity, high winds, terrain, and biomass levels. So we will be looking at how terrain impacts the biomass levels. Fires in San Diego County are often wind-driven due to strong Santa Ana winds, which typically occur from May to November. With limited rain in the winter, the chaparral vegetation is dry and can easily burn. The purpose of the field project is to 1. Understand the role aspect plays in species distribution and how that can affect fire patterns, to understand the role of slope percent and how it plays a role in species distribution and how that can affect fire patterns, and also by comparing burnt and unburnt locations, we can compare shrub biomass to understand how these 2 factors play in the role of fire patterns. The sampling plan can be seen here. 8 plots were chosen, each given an example of the type of terrain that can be found in this area. It was difficult to do a random sampling as there is limited access to some of these areas. So I tried to pick areas that were representative of the cardinal directions and that were present in both burnt and unburnt. I feel that this gives a good sample of the different aspects and slope percents and vegetation in this area. Each plot was 8 meters by 8 meters and represented thick vegetation cover. Again, the two plants that were sampled were flat-top buckwheat and California sage. The slopes varied depending on the site location, and all the site locations were unshaded. The percent cover, of course, was higher in unburnt areas as it was in burnt areas. This is a map that shows the 8 locations. As you can see, 1, 2, 3, and 4 are unburnt, which are in the southwest, and the unburnt or the burnt to the north. The fire took place in 2017, and I was able to acquire imagery that showed how the scar impacted to the landscape. The materials used in this project were a cell phone to identify the locations that I uploaded to the Esri online account, a string to map out the plot, measuring tape, and a notepad to record findings. A cell phone was also used to determine the slope. Shading and aspect and the plant species were determined by me in the field. Data was collected from each of the 8 plots. The diameter was determined based off data collected in the field. Data was gathered for each plot regarding slope percent, aspect, location, and plant percent cover. The average plant height was measured and calculated, as was the average of stems per plant. Due to limited resources and manpower, 6 plants of each species were measured and recorded to give a general idea of stem diameter in each of the 8 plots. Further measurements would be recommended. Equations from Riccardi 2007 were used to determine the shrub's biomass. The following paper was used to determine the equation that would best represent the biomass for this area. As you can see, the equation, loading, and the variables used were gained from this paper, and then the data collected in the field to gather the biomass for each of the plant species in burnt and unburnt. The results here are shown. The top is the California sage and the bottom is the flat-top buckwheat. Logically, it makes sense that there is more biomass in an area that has not been burnt in many years versus those that have been burnt. The California sage plant is a much thinner plant and not as dense as the flat-top buckwheat. This also means that it's not as resistant to fire. So at the site, I found it was often the case that the California sage was very small and very short compared to the flat-top buckwheat, which was better able to survive the fires several years ago. So that indicates that the flat-top buckwheat is a little bit more resistant and hardy to fire. I plotted the slope percent and the biomass of each of the plants. The first graph on the left shows the California sage. If you look at the graph, you can see that the unburnt areas, of course, had higher biomasses, but they also tended to be in moderate slope positions, whereas the burnt California sage, several were in the higher slope percentages, although there was an outlier of a small slope. If you look at flat-top buckwheat, the same can also be said. Higher biomass, but moderate slopes versus the burnt areas, which had a higher percent of slope. There seems to be denser populations of plants that are growing on west and southwest facing slopes versus east facing slopes. It was also observed that the fire that took place in May 2017 was most likely burning on west-facing slopes. With west-facing slopes having higher slope percents, this could be an indication that west-facing slopes are more likely to burn in this area. There are many factors that go into the spread of wildfires in San Diego County. Wildfires typically occur at high intense crown fires with behaviors influenced by high temperatures, low humidity, high wind, terrain, and biomass levels. If we look at terrain and biomass, we can see some of these effects and the effects they have on fire spread. While this study only looked at 2 chaparral plant species, this is an area with high biomass. So in many fires, they burn very quickly and can spread fast. Depending on the conditions of the site, wind is a big factor in San Diego. Many of the slopes in this study are greater than 50% and tend to be west-facing. Based on the data collected, it is evident that aspect and slope percent, along with high biomasses, can influence the spread of fire. While this might seem evident, it is interesting to put this into practice and see how the slope and its percent and what direction it's facing can really play a big role in how wildfires spread in this region. There are many hills in this area, not just in Mission Trails, but it does seem that when fires do take place here, they move from a west to east direction depending on the wind. In May 2017, the wind was coming from the west, but a Santa Ana had started and then began to blow the winds to the west from the east, which helped the firefighters put this fire out. Again, there are a lot of factors in how wildfires can spread in this region, and temperature and humidity can also play a role, but I felt it was interesting to look at just a few things to see how those specific terrain features and the biomass levels really do affect the spread of wildfires. These are the references used in this presentation. Thank you for your time.